Hi friends, in this video we are going to discuss about the previous gate question. Okay, next question. See here, a three-phase synchronous motor connected to AC mains. Three-phase synchronous motor connected to AC mains, running at full load unity power factor. Three-phase synchronous motor connected to AC mains, running at full load unity power factor. Nothing but the synchronous motor connected to bus bar, operating at full load unity power factor. If a shaft load reduced by half, if shaft load reduced by half, if shaft load reduced by half, with field current held constant, its new power factor is nothing but synchronous motor parallel operation with bus bar, and load reduces, then what happened to new power factor? In synchronous motor under unity power factor, if load reduces, then power factor reduces, but reduces nothing but lagging or leading. It is the leading. It is leading. When the load reduces, the machine operates it, and its new power factor is leading power factor. Reduces in leading. For this, we have a vector diagram actually. You can find in Syameda videos. In synchronous machine, you can find all exactly how when load reduces, when the load reduces and power factor goes into leading. Of course, general thing is when in a parallel operation, synchronous motor with bus bar, when load reduces, the machine operates under leading load. This is when load reduces with field current constant, nothing but constant excitation, effect of supply or effect of load. In that concept we can discuss actually. So when load reduces, the machine operating under leading load. Right, let's see the next question. This is a linked answer question. This is the common data. Synchronous motor connected to infinite bus bar at 1.0 per unit voltage and 0.6 per unit current. Unity power factor excess 1.0 per unit and armature resistance negligible. Then find the excitation EMF and the load angle. Excitation EMF and the load angle. Generally, what is the formula? EMF E is equals to V minus IA into XS. EMF E is equals to V 1 at an angle 0 minus IA 0.6 at an angle 0 degrees, because unity power factor cos 01 and XS 1 at an angle 90 degrees, because RA negligible. When RA negligible, theta is the 90 degrees. Now tell me, if you calculate this value 1 minus 0.6 at an angle 90 degrees, if you calculate this value, you can get 1.17 at an angle minus 30.96 degrees. Minus 30.96 degrees. 1.17 at an angle minus 30.96 degrees is a very easy question. Now tell me, what is your answer? 1.17 per unit and 30.96 degrees leading, or 1.17 per unit and 30.96 lagging? Which is correct answer? Which is correct answer? Actually, this is only the correct answer, because minus represents lagging load. Minus represents lagging load. Be careful. Okay, next question. Same data, next question. Tell me, keeping excitation voltage same, the load on the motor is increased such that the motor current increased by 20%. Motor current increased by 20%. The operating power factor, tell me. Actually, for this, generally for motor, for example, this is supply voltage. For example, this is the back EMF. The angle between voltage and EMF is delta, and sum of these two is taken as ER. This ER is equals to IA into XS. So ER is equals to square root of E square plus V square minus 2 EV cos delta from this diagram. So IA into XS is equals to square root of E square plus V square minus 2 EV into cos delta. What is IA? The motor current increased by 20%. So IA new is equals to 20% increased. So 120% of 0.6. 120% of 0.6. So how much it is? 120% of 0.6 is equals to 120% of 0.6 is equals to how much it is? 12 by 10, 6 by 10. 12 by 10, 6 by 10. What is the answer? 72 by 100, nothing but 0.72 amperes. IA new. Now substitute here 0.72 multiplied with 1 is equals to square root of E value. I calculated already E value 1.17 whole square plus 1 square minus 2 1.17 into V and cos delta. If you calculate from this cos delta is equals to 0.789. What about delta? Delta is equals to cos inverse of 0.789. This value 0.789, cos inverse of 0.789 value is the value 37.85 degrees. The delta value 37.85 degrees. Just I got delta, but actually I want the power factor. Power factor. For that I am doing is that generally E is equals to V minus IA into XS. IA into XS. From that I am calculating IA is equals to V minus E 1 at an angle 0 minus 1.17 at an angle 1.17 at an angle. Up to that we have that minus 30.9 degrees, 30.96 degrees divided by excess. How much excess? 1 at an angle 90 degrees. V minus E by excess. If you calculate this value, you can get 0.712 at an angle minus 6.31 degrees. If you calculate this, IA is equals to 0.712 at an angle minus 6.31 degrees. So generally this is the way IA at an angle phi. IA at an angle phi. Then tell me power factor. Cos pi nothing but cos of 6.31. Then we can get 0.994 lagging. Why you are taking lagging? Because of negative sign. The answer should be in lagging. The answer should be in lagging. Because of negative sign, the answer should be in lagging. This is the way how to solve it. Right? First, I increased my armature current. I substituted here, and we know the formula. From this, I calculated cos delta, then delta, and then we know the E is equal to V minus IA into XS. IA value, after IA, I calculated from this the power factor. Cos pi is equals to 0.994. Lagging is your answer. Next question, see here. The field excitation of 20 amperes in a certain alternator, results in a armature current of 400 amperes in short circuit. Field current 20, short circuit current 400 amperes. Internal voltage of 2000 on open circuit. EOC 2000. The magnitude of internal voltage drop within the machine. Voltage drop at load current of 20 amperes is. They want the drop I into some X. I into X, how much it is. So first we have to find out the X value. Tell me XS is equals to, or ZS is equals to, or XS is equals to EOC divided by ISC. What is EOC they given? 2000. ISC they given 400. So is a 5 ohms. Now the internal drop IL into ZS or IL into XS is equals to 200 multiplied by 5. How much it is? 200 multiplied by 5. 200 multiplied by 5 is the 1000 volts. Just we have to find out either XS or ZS. This value 5 ohms. Then the drop I into Z or I into X, IZ or IX is value of 1000 volts. So which of the following is correct answer? 1000 volts is the internal drop of the machine at 200 amperes of load. Right? Yeah, next question. Let's see here. 3-phase salient pole synchronous motor. This is salient pole. Connected to infinite bus. It is operated a normal excitation. Operating at normal excitation. The field excitation of the motor first reduced to 0. The field excitation of the motor first reduced to 0 and then increased in reverse direction. Actually. Increased in reverse direction gradually. Then armature current is. Actually, this is V curves. From the V curve, actually, this is the graph between armature current and field current. First, at normal excited condition, the excitation reduced to 0. When excitation reduced to 0, the armature current increases to maximum. Increases continuously. First increases. Maybe these two are the correct answers. These two are the wrong answers. Because first decreases is wrong, remains constant is wrong. These two are wrong answers. In between these two, one is the correct answer. Next, if the field current increased in reverse direction, actually when excitation is 0, the synchronous motor acts as reluctance motor. Synchronous motor act as reluctance motor. Then after, when the excitation increased in reverse direction, actually the armature current should decrease because we are increasing the excitation. That's why the armature current should decrease actually. Even though it is increasing in reverse direction, but the action is similar to in forward direction. The action is similar to in forward direction. When excitation increased in reverse direction, again the armature current decreases. So first increasing, then after decreasing. So which of the following is correct answer? First increasing, then decreasing steeply. Then decreasing steeply. This is 100% correct answer. Why? When excitation 0, the motor, synchronous motor acts as a reluctance motor, actually which drawing the more armature current, more reactive power. Then after, when excitation increased in reverse direction, even in reverse direction, the action is similar to forward direction. That's why armature current decreases. Next question, see here. The direct axis and quadrature axis reactance of a silent pole alternator, they given XD direct axis 1.2, XQ 1.0 per unit respectively, and RA neglected. If this alternator delivering rated kVA at unity power factor nothing but cos pi is equals to 1, sin phi is equals to 0, and rated voltage, then its power angle is, actually they want the power angle delta. Actually we have a formula, tan psi is equals to V sin phi plus or minus IAXQ divided by V cos pi plus IARA P. What is the formula? Tan psi is equals to V sin phi plus IAXQ divided by V cos phi plus IARA. Now substitute here. Tan psi is equals to V. What is the V? Rated voltage. So 1. What is the sin phi? At unity power factor, sin phi 0 plus IA. What is the IA? They given rated current. They won't give an IA. So IA is equals to 1 and XQ is equals to 1 divided by V cos pi plus IARA. So simply, what is the answer for this? 1. 1 by 1. So if tan psi is equals to 1, psi is equals to 45 degrees, xi is equals to 45 degrees. This is the xi. But actually for alternator, psi is equals to delta plus phi. Xi is equals to delta plus phi. What is xi? 45 degrees. Delta we have to find. What is power factor angle? At unity power factor, phi is equals to 0. So delta is equals to psi. Delta is equals to xi. 45 degrees is our answer. So tell me which of the following is correct answer. Option B, 45 degrees. So what is the formula? Tan xi is equals to V sin phi plus IAXQ divided by V cos phi plus IARA. This is the answer. Right, next question. The angle delta, nothing but load angle or power angle. In the swing equation of a synchronous generator is the nothing but the angle between The angle between, in that we have a one option, the angular displacement of an axis fixed to the rotor, with respect to a synchronously rotating axis. What is that? Synchronously rotating axis. Actually, this is the correct answer for the load angle delta. This is the correct answer for load angle delta. Load angle delta in the synchronous generator is, that is the question, the angular displacement of an axis fixed to the rotor with respect to synchronously rotating axis. How it is? For example, like this. This is the fixed to the rotor axis. This is rotor axis. For example, this is my stator axis and rotor axis. Actually, the angle between them is the torque angle. But this rotating axis, which rotating at synchronous speed, this rotating axis and rotor axis, in between these two is called load angle delta or power angle delta. The power angle delta is the angle between the rotor axis and the rotating axis in the synchronous machine. In between these two is the delta. The stator angle, rotor angle, the stator axis and rotor axis. The angle between stator axis and rotor axis is the lambda, is the torque angle. This is the torque angle, and this is the delta, which in the swing equation of alternator. Right? So finally, the angular displacement of an axis fixed to the rotor with respect to synchronously rotating axis. Right? Next question. Let's see here. A star connected 400 volts, 50 Hz, 4-pole synchronous machine. What is the voltage? The given star connected, in that line voltage is equals to 400 volts. So what is the phase voltage for this? The phase voltage is equals to, for this, the phase voltage is equals to 231 volts. How it will be? 400 divided by root 3 is around 431 volts. Yeah. OC and SC test are given below. EOC is equals to 400 volts or VOC is equals to 231 volts. This is the line voltage. This is the phase voltage. Right. At this condition, the field current is 2.3 amperes. The next, short circuit current 10 amperes. At this condition, field current is 1.5 amperes. For example, I am taking here the field current at rated voltage is taken as IFOC. The field current at rated current taken as IFSC. Then after, generally, the synchronous impedance ZS is equals to EOC by ISC. Its value 23.1 ohms. EOC by ISC, its value 23.1 ohms. Right? What is this value? This is the value of 231. So ZS or ZSC, the short circuit impedance, 23.1 ohms. What he asked? The per phase synchronous impedance. They want. So generally, this is the base value. Actually, this is the base impedance. Because of rated values, this is taken as the base impedance. but I want the per phase impedance. How? What is the formula? The formula is that per unit value is equals to actual value by base value. Per unit value is equals to actual value by base value. What is the actual impedance? Actual impedance is equals to per unit impedance multiplied by base impedance. Actual impedance is equals to per unit impedance multiplied by base impedance. Now tell me, what is our answer? This is the base impedance. Now we have to find out the per unit impedance. How, sir? How we can find out the per unit impedance? And generally we know SCR, the short circuit ratio, is equals to IFOC by IFSC. IFOC divided by IFSC is SCR, but this SCR is equals to 1 by per unit impedance. SCR is equals to 1 by per unit impedance. Now tell me, what is per unit impedance? The per unit impedance is equals to IFSC by IFOC, that is equals to, what is the field current required to rated armature current? Rated armature current 1.5, rated open circuit voltage 2.3. To get the rated open circuit voltage, the field current 2.3, then we can get this value 0.65 per unit. How much it is? 0.65 per unit. This is the base impedance and this is the per unit impedance. Base impedance and the per unit impedance. Now I want the actual impedance. Tell me the answer fast. Calculate it. So actual impedance, Z actual is equals to Z per unit multiplied by how much? Z phase 23.1 ohms. 23.1 ohms. If you calculate this value, the actual impedance per phase is 15.06 ohms. 15.06 ohms is our final answer. So what I done? Actually, we have to find out the per unit impedance. We have to find out the actual impedance. For that, we have to find out per unit impedance and base impedance. If we have a per unit impedance and base impedance multiplied by per unit impedance with base impedance, we can get the actual impedance. So how we can find out the base impedance? With given values, base values, rated values. Yeah, EOC by ISC gives us base impedance. Then after per unit impedance is equals to 1 by SCR, then we can get the per unit impedance. If multiplied this both, then we can get the actual impedance, which is our answer. Right, next question is based on synchronization. This question based on synchronization, right? Let's see. A three-phase alternator is to be connected to infinite bus. Three-phase alternator parallelly operating with the infinite bus. Three-phase alternator with infinite bus. The lamps are connected as shown in figure. Lamps connected as shown in figure. Like this. In R phase, R dash. And Y phase, Y dash. And B phase, B dash. Like that connected. Right, okay. And that of the incoming generated voltage R dash, Y dash, B dash, like that are there. Now it was found that the lamps are become dark in sequence A B C. The lamps are become dark in sequence A B C. It means that the phase sequence of the incoming generator is, if the lamps are sequentially dark, A, B, C, like a darking, so it means that the phase sequence of incoming generator is, this is the question. So generally, when these are connected like this, if the lamps are dark and simultaneously bright and dark and simultaneously bright, then it represents that both are in same phase sequence. Yes or no? Bright and simultaneously dark and bright simultaneously dark. When the lamps are connected like that, when the lamps are glowing like that, then both are in same phase sequence, in same. But here, these lamps are sequentially, A, B, C, sequentially becoming dark. Nothing but which the statement is correct in between, in the these four, which statement is correct answer for this? So which statement is correct? Opposite to. It means that the phase sequence of incoming generator is, the phase sequence of incoming generator is opposite to infinite bus bar. Opposite to infinite bus bar, its frequency is more than infinite bus. Its frequency is more than infinite bus because it's just becoming dark. But we have to do that for synchronization, simultaneously bright and dark. Dark. In that condition, we have to close the switch. But he said that just becoming the dark. Just becoming the dark, nothing but the phase sequence is exactly opposite direction, and the frequency is more than infinite bus. This is the actually our answer. Right, next question. See here. A 20 pole alternator, 20 pole alternator is having 180 identical stator slots. What is that? 180 identical stator slots with 6 conductors in each slot. 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 All coils of a phase are in series. All coils of a phase are in series. If the coils are connected to realize single phase winding, if the coils are connected to realize single phase winding, the generated voltage is V1. If the coils are reconnected to realize three-phase star connection, the generating voltage is V2. The generating voltage is V2. Assuming full pitch single layer winding, then find V1 divided by V2. V1 by V2 is equals to how much it is? Yeah, tell me, generally, this is the problem like we already saw in previous question. This is the problem like EMF per phase in single phase to the EMF per phase in in three phase. EMF per phase in single phase to the three phase. For this, I given you one formula already. What is the formula? Have you? For single phase, M beta is equals to 180 by 1. For three phase, M beta is equals to 180 by 3. So, what is the formula for this? Sin M beta by 2. What is M beta? 180 by 2. Sin 180 by 2 divided by sin M beta by 2. Sin 60 by 2. Sin 60 by 2 multiplied with its M beta. What is M beta for this? 60 divided by, what is M beta for this? 180. It's the answer. No need to go like we have to find out the conductor, we have to find out the EMF for single phase, then after three phase. No need to do all. Actually, we have the formula. So now tell me what is the answer? Yeah, sin 90 is the one. Sine 90 is the 1. And what is the value here? Sine 60 by 2. Sine 60 by 2. Sine 60 by 2 is 1 by 2. 1 by 2 multiplied divided by 61. 63 is 1 by 3. And again we have to find out EMF, right? So we have to multiply with number of tons. What is the formula actually? The EMF is directly proportional to Kd into number of tons. Kd into number of tons. Now tell me, what is the number of tons for this? The T phase is the T by 1. And what is the number of tons for this? T by 3. T by 3. EMF directly proportional to Kd into T. So tell me, what is the answer? This T gets cancelled, is 3 by 1. So what is the answer? 3 gets cancelled. So our answer is 2. Our answer is 2. Very simple question. Very simple question. See, just once again see here how we are doing like this. How we are doing. Once again see here. Once again see here clearly. For this we have a formula. E is directly proportional to Kd into T. E is directly proportional to Kd multiplied by T. For this, sine m beta by 2. Sine m beta by 2 divided by sine m beta by 2. Sine m beta by 2. For this m beta 60 degrees. For this m beta 180 degrees. Multiplied by m beta of this one 60 degrees and m beta of this one 180 degrees multiplied by number of tons per phase T by 1, number of tons per phase T by 3. T gets cancelled once or thrice. So what is your answer? 1 divided by 1 by 2 multiplied with 1 by 3 multiplied with 3 by 1. 3 gets cancelled. So our answer is 2. So V1 by V2. This is the formula for V1 by V2. This is our answer. V1 by V2 is equals to 2. Simply is equals to 2.